Welcome, and thank you for joining us. TST and VISI would like to present the VISI 2022 release update for the CAD side of the software. Before we begin, I'd like to go over some of our support services that we offer. So TST offers some on-site and web training. This includes rollouts, this includes anything. We also offer helpline support via phone, email, and our website. And we also offer tech days such as this for our webinars. And an unmatched level of support. As you guys know, you call us, we typically will give you answers. You email us, we will give you answers, and so on. So just re-mention again, we offer technical support days. So with this new VISI 2022 release, we offer rollout days. So basically what this rollout would entail is we would do the install work for you, creating and transferring all your custom libraries, and also just making sure everything is quick and seamless going from previous version to 2022. So if you're interested, feel free and contact us. So here's the criteria that we're going to be going over in this section. So we're going to be going over the installation, translators, user interface improvements, the CAD graphic and picking options, some drafting and modeling commands, reverse, mold, flow, progress, and our standard element package. So these are going to be the updates that we're going to be showcasing for each of these modules. So we'll go into some of the installation prerequisites. So within the VISI 2022 release update, you do need to be on Windows 10, the Pro version of Windows 10 and 64-bit. Windows 7 and Windows 8 are no longer supported. And files saved in 2022 cannot be opened in VISI 2021 or previous versions. So as we mentioned, Windows 7 is in sunset stage. Microsoft no longer supports it, so our suggestion is to get up to date with Windows 10 before installing 2022. So we'll go into some of the new translators within this version. So some of the new supported import translators include CATIA v6 2021, Inventor 2021, JT Open version 10.5, NX versions 1926 to 1946, Parasol versions 33.0.247, Revit engines from version 2015 to 2021, Solid Edge 2021, SolidWorks 2021, and the new ability to import step zip files. So here's just a list of everything that is included within the import options. The ones highlighted are the ones that are new inside of 2022. So to go over some of the new export functions, these include CATIA v6 2021, a new translator to be able to write out NX files, 3D PDF wireframe exports for the alternative translator. And here's once again a list of the new export options. Highlighted are the new features in 2022. So within the alternative translators, there's been a continuous and constant consolidation of these interfaces which have been carried out in order to make the most of their peculiarities, including the availability of some of the new formats, including JT Open, Revit, and the Write NX translators. So within the NX Writer, there is a new tool for writing NX files, which allows you to export the PRT models from VISI. This includes any assemblies and so on. Within the Revit translator, it is now possible to import both RVT and RFA files coming from Revit of Autodesk. So you can see some file examples. So also within STEP, you now have the ability to import in its compressed format. So the SPZ can now be imported in. We now have the ability to do a 3D write within the 3D PDF using the alternative translators. There's been some great improvements with this, which includes the visualization of the structure of a part. You can now display or remove body edges. You now have the ability to import and export with translators. And you have the ability to import in wireframe to the 3D PDF format. You can also write out work planes from the 3D PDF format as well. So here's just a couple picture examples just kind of showing that. So here's just a video real quick, just showing the 3D PDFs. So you have your different translators. You can see they're both showing up as mesh model. We can change rendering mode to solid, and you can see your wireframe is now imported in. You can see how when you rotate, you can see the mixed rendering options. You can turn on and off different sections if you're exporting this out by assemblies. Now, the one thing to note, once again, with that is those were written out with the alternative translators. Traditional will still function the same exact way when it comes to exporting out a 3D PDF. So there's also a new PCDMIS import. So we have a direct interface from PCDMIS that has been introduced. So CAD files export out of PCDMIS can now be directly imported into VISI. So this improves the linking between the two products. So the loading possibilities are available depending on the traditional or alternative. So both of these will be able to open them up. You just have different options when it comes to the import options of these. So here's just a couple pictures just showing in VISI and PCDMIS. So we have detection of format versions. So for example, when a file is failing to import, either by an unsupported version or missing files, it will now show you this error message and pop up with a notepad showing you the information. So as you can see, this is a solid edge file version 12. VISI only supports up to version 18, and so it shows you that information. And for example, if you're importing in a PRT file and it's associated to other PRT files, it will highlight the missing files as well. So we have automatic import transparency. There is a new option in the graphics tab under system options that makes it possible for you to import bodies to get an automatic transparency value naturally. So as you can see, when we select this option, it will choose the transparency based on a file. So not everything has to be 50%. So you can set it to whatever you want. We'll now go into the user interface improvements. So there is a new option for read-only mode inside of VISI. So this new command is just under the file dropdown, and it's just called read-only mode. So if you select this option, regardless of whatever file you open, it always opens in read-only, and it doesn't prompt you anything at the beginning of the file opening. We now have the ability to do bolded dropdowns. So this new option under System Settings, User Interface, allows you to bold your dropdowns. Anything that has sub-dropdowns in it, it will also bold those commands as well. We have a new drop-down location improvement. So the commands have been moved to submenus within the drop-downs to help clean up the drop-down sizes when using large icons. This eliminates the issue of, let's say, using the edit drop-down and accidentally selecting undo instead of going to the edit drop-down and choosing the command you want. This also has been improved with the annotation drop-down and analysis. So you can see the before and after effects of all these sub drop-downs. So you can see we've got the edit drop-down, we've got the analysis drop-down, and the annotation drop-down. So you can see how these sizes and the commands have been improved upon. So within the solid drop-down, it's actually been renamed to surfaces actually. So the modeling drop-down also now includes the forms commands. So you can see surfacing commands are now actually in the surfacing drop-down, no longer solids. The modeling commands to create 3D blocks are now moved to the modeling command instead of solids. So this is an optional enhancement. Under question mark, we have a remote support option. We have developed some new options to be able to set it to link to GoToAssist. So with our support team, we use GoToAssist. All you have to do is just enter your name and support key. No longer do you have to go to any websites. You just go right inside of VISI, question mark remote support, and it will go right to it. So within this takes some initial setup. So included with the installation area, there is a VISI GoToAssist zip file, which includes 3 different files: the extend3d.mnu, the GoToAssist executable, and a README PDF, basically just showing you the step-by-steps on how to implement this. So if you need any assistance with it, feel free and contact us at support as well. So from here, we're going to go into the new options within the graphic and picking selection area. So there is a new option called Change Layer Index Number. So within the layer index, you now can right-click where the index number is and change the index number. This moves your layers to a different destination layer. So when you're in the destination layer, it doesn't have to have a name in it, and it will fill in the source layer. So when there is a destination layer that contains elements in it, they will be preserved, and the element in the original layer will be moved to it. So the new option within this is right-clicking on the index number and selecting Change Layer Index. And again, as we mentioned, if you change that index number to a layer that has data existing in it, you'll get this warning message, which allows you to move the data to that layer or merge the data to that layer as well. So here's just a quick video showing this. So if you right click on that layer index, you can select Change Layer Index. You type in a number, for example, 6 to 7, and that moves that layer. What's nice about this is the layer groups will also retain to whatever group that was previously associated to. So for example, you can see how that layer index merges. So if I merge this now onto index 8, it will pop up a warning message just showing you that information. You hit yes, it merges that data. You hit no, it will leave that layer where it's at. So there's some new graphic options for shading as well. So you can control the lock transparency. So whatever your transparency is for locked items, you can control the transparency of it. You can change the relevant edge thickness. You can change the split line edge thickness, and you can enable and disable free face transparencies. So here's some of the new options. Here's just a couple images just showing those. And these are under the System Settings Graphics area. We have some new brush stroke selection enhancements. So the command is actually originally been in the software, but now you have the ability to change the brush stroke selection. So anytime you're in a selection area that involves picking elements, if you hold the Alt plus the wheel mouse button, you'll see a brush selection stroke. So this is another ability or another option for being able to select your items. So within this option, you have the ability to change the sizes as well. So we also have some enhanced picking for center points. So within circle centers, face centers, and spheres, so on, you have the ability to now pick a point in the enhanced pick options without actually having to change your filters. So all you do is just highlight the face, it highlights the center of it. So no longer do you need to use, like, let's say, an equidistance of the center of a face, and so on. So here's just a couple quick videos. So you can see here's your locked items. You have this lock element transparency. You change that transparency and it changes the transparency of the shading of that option. So you can see we're in transparency shading with outline. If we go into System Settings Graphics, you can enable and disable the face transparency mode. So you can have a toggle button to turn that on and off. Within System Settings as well, you have the ability to change the brush sizes. So if you change that brush size right now set to 30, if you use the Alt and wheel mouse button, you can see how that brush size is now set to 30. This allows us to be able to select different items. If you turn that option on and off, you have the ability to toggle it. If you set it to 10, it makes that brush size smaller. You set it a little bit bigger, like let's say 50, you have the ability to change that brush size to make it bigger. And then we have our enhanced pick point selections. So anytime we're in a command that involves the enhanced pick point environment, you see how you have the ability to instantly select the center of a cuboid, center of a circle, center of a wireframe drawn circle, and it will automatically put a sketch point for you to be able to snap to and pick from. With mesh selection or selecting triangles, we have some improvements as well. It is now possible to select a triangle and create the maximum deviation without having to go back and forward within that maximum deviation. So this allows you to toggle to increase and decrease the amount of triangles that it's possible to select without completely backing out of the command. So there's a new selection mode within the triangles using adjacent faces to select the piecewise as well. And within the brush selection, we have the ability to pick the windows using the Alt wheel mouse button, just like what was shown before. So this the glow line is now highlighted only on the highlighted mesh edges. And we have an option for this, use glow lines on highlight, that's already been available. You can change that highlight thickness option, which only, again, affects the triangles that are highlighted. So here's just a quick video showing that. So if we go to change attributes and we're selecting your different information via mesh, you can select change attributes. You pick one of the triangles, and we're in the deviation mode. You can increase that option without having to back out. It previews it automatically, and you increase it to the point that you need to be able to select all your triangles. And you can see how it brings up the menu here. You can change the triangles to whatever you want. So we can enable this new select piecewise triangle selection here. And you can go ahead and use the drag window, and it selects the triangle specifically using that piecewise option. So you can see how when we're dragging the window, it's selecting those triangles. And we also have the ability, if, as you can see, when it's turned off, it selects all the triangles, whereas the piecewise only selects the specific top triangles. So just repeating that process again, you can see how it's selecting only those pieces instead of selecting all the triangles overall. So this makes it really easy when it comes to selecting a mesh to only pick specifically what you're looking for. And then lastly, we have the brush stroke selection. Just like what was shown before, if I hold the Alt and wheel mouse button, I can pick these triangles specifically with the brush stroke. So you can see how it's painting your selection on your dialog, and it's only picking those triangles. So as you can see, we now have the ability to select those with the brush stroke as well and change brush stroke size. Continuing on with my selection, you can see how we're continuously selecting our triangles. So it makes it easier for being able to pick the triangles and pick the specific triangles that you're looking for. We'll now go into the new features within the drafting and modeling modules inside of VISI. So within the translation command, you now have angle input options. So you now have the ability to input in an XYZ angle, and the angle values reset every time you go into the command. So here's the image of the new commands. And inside of Assembly Manager, it now will automatically update with new entities regardless of if you're in the command or not. So if you add a new block, it automatically updates and adds it into Assembly Manager. So within the pattern Boolean options, it is now possible to be able to pick from pattern commands within the Boolean options, and it will create instances for you. So for example, you make a change to one, it will make a change to them all. So when you create instances, this allows you to do your rotations, mirrors, and open pockets. So within open pockets, you have the ability to rotate and mirror those options. So here's just a quick video example. So we go into the pattern, we're going to go into, let's say, rotation. You can select the whole feature that you're trying to rotate, choose the direction, and this allows you to make a copy of it. And when you make copies, you have the ability to create instances of those copies. So for example, we have equal spacing and full rotation. And for example, when you do this, you have create feature instances as well. So when you make a change to one feature, it will actually make a change to the other features as well. So it gives you some error messages letting you know that some of these features may not be installed properly based on the parameters that you have set. So the warning message has been improved upon as well. So if you do equally spaced and so on, it will show you that warning message if you are manually creating the angles. So now that I have the angles created with instances, you can see in the SolidWorks Manager, you can see all of those features. You can unlink those features, you can delete the features out, and so on. So being that these are now created in the SolidWorks Manager with the create instance command, if you make a change to one of those features, it will change them all. So for example, if I add a chamfer to the top of the feature, it adds a chamfer to all of the features. So this is nice for being able to edit and adjust whole features. The same thing applies for the translation portion of the pattern command. So you can see how we have different features in here, different pockets. And we could say, let's say shift this 30 millimeters. We can make multiple copies, and it shifts those copies as well. So you can see we have our different pockets, different areas. You can increase and decrease the number. It will give you a warning message if it's, let's say, colliding with a blend and so on. So it does give you those warning messages. So that has also been improved with it. You can see the create feature instances option as well. So you can see when we highlight all of them, we're now going to translate them in the Y direction. And we'll make multiple copies. So each one of these, it is created as an instance. So you make a modification to one, it makes a modification to the rest of them using that create feature instance. You can see under the SolidWorks Manager, there are all of our features as well. Again, we can unlink and delete those features too. But for example, if we make a change, like let's say adding a blend to the top, it'll add a blend to the top on all of them just by simply picking one edge. You can edit and adjust the lengths or edit and adjust the faces as well, and it will improve those as well. So if we go to edit faces, we pick this bottom face, changing the length, it changes the length for all of your features. So as you can see, we can adjust it and it improves that length as well. We can use any commands that we want, edit constant radius blend. So basically any commands that we want, and it will update them all the same exact way. So you can delete those blends out, and it deletes it out for all of them. We can change the blend radiuses, and it adjusts the radius for all of them as well. So you can see how it's adjusting that blend radius for every single item that you have listed here. If I change one blend, I just say delete, or change the radius again, it will update and change those relevant values for every single one. As you can see, the create instance does make those adjustments for each item when it comes to the create instance command. You can see we have all of our different features here. You can see how we have all of our different areas. If I do a cut body, what's nice about this is you've got one plate, and what it's going to do is it's going to automatically subdivide it based on where your features are created. So if we do a cut bodies, you can see how it still splits them up. It splits them up as separate entities. So for example, if we make a modification with the cut bodies, it only adjusts the cut bodies for the specific area that you have highlighted. So if you cut the bodies, it splits those bodies, but it's going to remember the other ones. So if I delete this one out, and then I make a modification to the other two, it will update in relevance to that. So you can see how it automatically separated out those bodies via a cut body. And if I unlink this one, for example, and I make a modification, it's not going to include the modification on the bodies that were cut, and it's not going to include a modification to the one that we unlinked, but it will include the modification on the others as well. So it's remembering the create instance, and it's doing it on all of those other ones, but it doesn't retain it on the separate body that was split, and so on. So here's just an example of an open pocket here. So as you can see, we have our open pocket on the outside. We can use our pattern commands to be able to translate that pocket. So if I select the faces here, select the area I want that to rotate around, you'll see when we say copy elements and we put 90 degrees, it's going to rotate that element. You could say multiple copies, and it's going to rotate at every 90-degree instance, and so on. And we can select create feature instances as well. It is now possible to add a blend to a surface corner. So you can add a blend to a laminar edge. So for example, picking two edges without having to create a thickness, you now can add a blend in it. So similar to how the fillet command works. There's also a brand new command called create middle curve, which makes it possible to create a curve between the chain of two edges or curves. So within the replace with surface command, we now have the ability to set an offset value within the dialog box. So within the replace face of surface, you have the ability to set offset values, which creates that offset between the two faces. With create trim surface, there's a new option to automatically extend the trimmed elements, including edges, to have the ability to create a closed loop with the trim selection of surfaces. This gives you the ability to extend the surface and touch each corner of the surface, even if there's any kind of little gaps in it. So in this video example, we're going to start out by showing off the blend commands. So we're going to pick 3 different edges here. You can see how it's going to create the blend between those 3 edges. So as you can see, we have the radiuses in here. We can increase and decrease the radiuses. So we'll go on to the next example using select peripheral edges of a sheet body, where you can pick these edges, right click, and it creates that blend on all of the peripheral edges as well. So this makes it an easy selection to be able to add the blends to a surface area. And then even more impressive than that as well is we have the ability to, let's say, create a blend between edges. So we look at this area right here, and we'll use the select peripheral edges of a sheet body for this as well, and allow it to be able to create the blends between those peripheral edges too, even on something with some 3D shape and 3D contour like this one. We can also change it to the select tangent edges here too, and add that blend to tangent edges off of a surface. So you can see how it takes the tangent edges and not the outer edges when it comes to our selections. So then we're going to go into wireframe, other curves, create middle curve. So between 2 curves, 2 edges, we have the ability to create a middle curve, and it creates a nice tangent middle curve. You can change the tolerances and increase that as well. So we can also create middle curve, you can see, off of edges as well. And then create a middle curve between blended areas too. So you can see how it creates that middle curve between 2 blended edges as well. So it creates wireframe lines between 2 blended areas, and you can see how it's going to create that. So then we have our replace face with surface option. So if we go to replace face with surface, we pick the specific face we want. And we can either pick your edges, you can pick your surface, and you now have the ability to set an offset value for that specific face. So as you can see, we can uncheck offset value, and it's going to not leave the offset value or leave the offset value depending on the settings that you have chosen. Same thing applies here as well. So if we pick our face that we want that to be offset to, then we pick our other faces, so we're doing from face to face, it does the offset value as well. So it's going to offset from the faces that you choose from. So it'll have that ability to set the offset between those faces using the replace face with surface. And then let's say we have faces within faces as well. So we have the ability to also set that offset value in relevance to those specific faces too. So these faces don't exactly match on each side, but we can pick those faces and allow it to do what we need it to do. So you can see how we can pick this face, we can pick the other relevant face, and it will actually set the offset values to whatever option that you want. So you can see how there is that offset value between those 2 faces. This is a nice improvement, enhancement when it comes to trying to, let's say, create a core and cavity block in upper or lower and so on, and you need an offset value between them. So then we're going to use the trim surface command. You can see how we have some incomplete curves in here on this shape, and this extend element trimming option allows you to extend those trimmed lines. So you can extend them out, and it's going to extend them out so it allows you to trim on something that's not such an ideal curve or edge. It allows you to create that edge or curve and basically connect the areas together to allow you to trim on not so ideal geometry. Reprocess curves has some new options. There's a new setting to repoint the curve to create approximate curves, and you have the ability to select a polyline to simplify the curves. Within delete extract faces, it is now possible to turn on and off the preview command on startup. So this specifically allows you within the delete extract faces command to turn this option off. This avoids any unneeded slowness when it comes to selecting it. This was something that was given to us via feedback, where the delete extract faces command would go very, very slow if it were set to, let's say, delete and heal depending on the face that you had, if preview command on startup was turned on. So you have that ability specifically to this command to turn it off. Extend surface. There is a new feature that allows you to extend the surface normal to a surface on selected edges. So you have the normal option as a new option. And there's a brand new command in the analysis dropdown called join curves, which is an alternative to simplify edges, in which it is possible to select a chain of curves to join them together to make one unique edge. Within the Boolean commands, the move and copy options have actually been renamed to retain target and retain tool bodies. These options work separately from each other using the target or the tool bodies, and these options are included with unite, subtract, and intersect. So you can see the difference between 2021 and 2022. Within edit faces, the command has been improved to allow you to do the following available options. So you can change radiuses to specify the intersected value for the new radius. You have the option to click automatic intersection, and you have the pattern options within the edit faces command as well. So we're just going to showcase these in a quick video. You can see that with the unite command, we have retain target body and retain tool body. These are now separate from each other, so you can retain one or the other. For example, we'll start out with retain tool bodies, so we pick our target body first, we pick our tool bodies. You can see how when we highlight it, it looks like there's some additional tool bodies there. That's because there is. If we hide our united body, you can see the retained tool bodies that are now there. So if I undo these real quick here, we're now going to select retain target body. So if we pick that as the target body, and then we pick our tool bodies, it will now retain just the target body. So if I hide my united area, you can see the target body is now retained separately. So instead of saying move a copy, we now have those separated out. If we select both, it will now retain both if they're turned on. So if we select our target body, our tool bodies, we have the ability to now select both. So if we hide our united bodies, you can see the separated tool and target bodies now retained. Within the edit faces command, we're going to show some of the new features within this. So if I pick, like, let's say this face and this detail right here, we now have the ability to change the radius options. So we're going to retain and reset the rotation center. And we're going to change our Z angle. So we can pick between two elements to figure out what the actual angle is. And we can select this option right here. And we can say offset reblend. And you can change that size of that circle as well. When we select change radius, you can select the radius value, and it's going to actually change that from distance to radius. So you can type in a new radius in there on the fly. And just like with our pattern commands that we were showing earlier, within edit faces, if I pick this face right here, I have the ability to actually transform and create that face on the opposite side. So, for example, if I change my rotation center to a different area, I can then rotate it 90 degrees or 180 degrees, and you can see how when we make our changes, it's going to change the open pocket as well. So you can see how we actually change that angle in relevance to that face. We can pick that face specifically as well, and we can make those modifications. We can translate that face wherever we need to, and so on. So as you can see, we now have the pattern translation commands in here as well. So you can make a copy of it, you can make multiple copies of it, and so on. So new inside the edit faces is we have the pattern translate commands within there when it comes to selecting a face. If I pick this face again, we can input it in a negative direction as well. We can make a copy of it. We can translate it, do whatever we need to do with it. So selecting copy elements, you can see how we take that open pocket and we translate it to whatever direction we need to do at whatever distance. You're just simply dragging the arrow, type it in your value either there or inside the dialog box on the right. Within fill holes, when it comes to selecting edges, you now have the ability to select the heal wounds option. Inside a bounding box, there's been some new enhancements to be able to display all points, center point, and so on. So you can actually hit this checkbox to say all points, and it displays all the points, including the center points off of the edges, the edge points, and so on. So we'll just show these real quick here. So if we go to fill holes, we're doing this in reference to the edges. You can see how if we select our different edges here, it says originally operation not possible. We now have the ability to select heal wounds, which actually heals that wound out and allows you to unite and join those patches together, basically making it so like that hole was never even there. So with the heal wounds area, it will bring it in and make it tangent and make it look just like as if that hole weren't there, and so on. Within the bounding box command, we have the ability when we're selecting our faces to display all points. So this actually creates a point on all of the areas. So including your centers, your edges, and so on. Within query geometric properties, inside of this, there are some new options to display profile element tangencies. You can also display the hatch lines for this as well when it comes to geometric properties. This is more specific to picking faces, but you have the ability to pick those options. And inside of dynamic section, there's been a lot of improvements with this as well. There's a new option to be able to create a dynamic mode. So within this option, you have 3 new options within this. You can change this from 1 plane, 2 planes, and you can also do this as a bounding box. When you're creating your section inside a dynamic, you have the ability to create the section as if you were doing it as a bounding box as well. So it is possible to hold your left mouse button now on those green arrows, and you can actually hold the left mouse and let it toggle through the sections based on your step value as well. So here's just a quick video demonstration of that. You can see we have the dynamic section, and we have a new option for dynamic. You can do the dynamic section off of 1 plane. You could change that drop down in there, and you can select 2 planes. You can change the rotation center. You can change your options as well to change where it's going to actually create the section. So I'm just simply holding the Alt key, and you can change that section in relevance. Change the X, Y, and Z values, and so on. You can even rotate this section too. So for example, if we change a rotation section, we have the ability as well to go to planes, and you can change it to a different plane as well. So again, changing the directions and so on. We can change this now to 2 planes. With 2 planes, you can now set your dynamic section in relevance to 2 planes. Each plane can be at a completely different angle, but you can cut your section in relevance to 2 different planes. So for example, you just drag in and drop in the arrows. You can type in the step values. You can increase and decrease those values, and so on. So for example, we can change our rotation centers. You could change your application point for where these are going to actually be translated at, and so on. So as you can see, it's cutting the section in 2 planes. Then if we do our dynamic section here, we can also do our dynamic section in relevance to a box. So this is like a bounding box where you're cutting your section in relevance to the bounding box. You can take your arrows, drag it out. It's doing a non-uniform bounding box. You can check those options for the uniform bounding box as well. And you can do a bounding box in the X direction, the Y direction, and the Z direction. You can also do it in a positive, negative, and the X, Y, and Z, just like you would do in bounding box. So you can see how you're creating your section, you're cutting your section in relevance to those dialogues. So if we check these options, you can do it just in a positive, just in a negative, or in relevance to length, width, and height of the specific part. So you can see this command has been vastly improved upon, makes it a lot better when it comes to presentation purposes. As you can see, you could drag your X, Y, and Z, and you have those new options within the bounding box command. So you can also change the rotation center. You can change your application point for where is it actually going to be translating from, and you can update those relevant values based on those options just by doing simple drag and drops of where the center application point is. You could turn on the show plane, and you can see the plane based in relevance to that box as well to make it bigger, make it smaller, and so on. So again, non-uniform versus uniform, you can make the adjustments as needed. So there is also another new command called solid interference. This is available under the analysis dropdown. So this command allows you to create selections off of elements which calculate the intersections of contact areas. So you have different phase colors for different intersections, and it's possible to cycle through each single intersection area. So here's just a quick video of that. We have the solid interference command. You can highlight your entire piece, and it will show all of your intersection areas based on different colors. You can show only the intersections or only contact faces. You can see how they all relate to different colors. So you can show the interference zones and so on. And you could do this by specific solids. So it also would change the color of the solids automatically to show you which solids are different. You can go through each result and you can go back and forth. You can see which solids have interference, and you can use your selection filters to display what solids are actually going through. So this show interference shows any kind of interference within a model. So you can actually pick specific reference bodies, and it'll also pick reference bodies to be able to do this by selection. You can show a label, you can show the volume and the area of these areas. You can keep that label, and you can do an automatic zoom on this option as well. So if I say keep layer or keep label, it'll keep the label when I confirm. So you can do by solids, so you could change once again the results, and it will keep a label at each interference area to allow you to see where you have collisions, where you're having contact faces, and it's just another checker when it comes to creating your models. So this is a big one as far as being able to see if there's any kind of collisions within your model. Inspection points. There's also a new command in the analysis dropdown called manage inspection points. This allows you to have the ability to create a point set for probing on a solid. And it's possible to edit each point sets as well, and it gives you the option to show a path by the order of your point sets or by the order of how you're selecting using the graphic sliders. This also allows you to check the collision of a sensor, and has the ability to export out a text file showing all of your points. So here's just a quick video of that. We can select the Manage Inspection Points, and you can select your part. You can create different inspection points. You can see how the arrows are in relevance to the specific face you're choosing from, and it will create inspection points based on the order of how you're selecting these areas. So for example, we're picking these areas, and we're picking the order of where they're going. You can see how it shows the points in order. You can change the order of how they're going to be. You can see how it selects the order, and it creates a path for you automatically off of that. So that path can be shown in a Z value, or the value of, for example, when that probe is going up and down. And you can see with just the ordering of it and relevance. So when you confirm, it actually confirms and retains these areas. So you can actually preview a sensor within this, and you can select your different inspection points. You could change the ball diameter, the rod diameter, and so on for that specific inspection point tool. So you can see how when we're moving that tool into an area, it will show any collisions and relevance to the tool when we're moving it around the part. For example, if we go back into the command, we select those different points, it'll actually automatically go right back into the specific points that we chose from. So as you can see, if you already have your inspection points in, you can delete points, you can add points, and so on, but it allows you to go right back into the command just by picking the specific points if you were not in the command. So we're going to now add some more points, this time in different face directions. You can see how the face direction is automatically going to be chosen based on that specific face to be able to create those inspection points. So we're just continuing to add points into our area, and it adds those relevant points to the area as well. So you can see how that path changes. You can see how it's basically creating your path for your probing points based on the inspection point command. So when we change our setups, that's the setup it's going to be relevating the points to. And we can also export out a text document showing each point. So it shows you where in the XYZ each point's going to be, as well as the work plane direction for each point. So you can show it in a text window. You can update that text window, and you can basically edit and show how it's separating out your values by a space, by a comma, by a semicolon, and so on. So it's going to show you this text document and allow you to display that area. Now we're going to see what is new in the reverse side of the VISI software. So we'll start with point scanning. It is now possible to directly scan using an RS² device provided by Hexagon into the CAD software. So this device allows you to scan the part, not creating different strips on the model by just taking square pictures of the part, creating a relative point cloud. It is now possible to create the mesh directly as a result of the scanned operation. Planes and cylinder probing. To guarantee the possibility to create the surface modeling directly from the probing function, a general constraint method has been added to allow you to create wireframe and even the surface using the work plane as a reference without picking any direction or surface, which is still valid as an option. Points to mesh. There has been some new features added to the point to mesh to guarantee the best result possible to start creating the mesh. The user can use these options to achieve a good mesh, optimizing in order to have less triangles in planned areas and more triangles where needed. Fill gaps. In this feature has been added a new method to fill holes on a mesh, which gives you the opportunity to create a bridge of triangles on the mesh. This function is very useful for holes that are on the outer boundary of a mesh, so you can actually create the mesh on a border and then fill it in as an internal hole. So here's just a quick video example of that showing this. So you can see how we have a couple of outer mesh areas. So we go into this meshed area, you can select it. You can see how we can create a bridged mesh. So let's just say picking a couple of points. So we pick a point there, pick a point there. And what that's going to do is that's going to create a bridged mesh to be able to fill that hole in. So as you can see, we have that bridged mesh in here. And now we can select fill, and it allows us to fill in the hole on the interior side. So as you can see, we fill that internal hole by selecting it as a bridge first, and then it creates a mesh off of that. We can adapt a mesh to an element. So this feature, which helps all users to using the mesh adjusting tools. In previous versions, we already had the possibility to adapt a mesh to a circle or a profile. With this new command, we can also adapt a mesh to a shape, such as a square, a rounded slot, and the user can decide whether the shape is drawn just to the wireframe, the element, or automatically adapt it into the mesh. We can also review calculated dimensions and adjust the position on the model. Another option available on this command is the feature to be able to add and easily detect the pocket on a mesh just by creating a relative wireframe element, or even adapt the mesh to a feature. Mesh optimization. So the command also allows you to better recognize and reduce the number of triangles on a mesh using different options available. The system will modify the mesh showing the results, which the user can elevate and adjust in reference to the desired results. So for example, we'll just show this quick video. We have different triangle mesh areas that may not be so ideal. So we can use the mesh optimization to start cleaning that up. If we do the initial selection here, you can hit preview, and we can let the system try to define the amount of triangles on plain areas and on, let's say, more complex blended areas. So you can see how it reduces the amount of triangles and relevance to certain areas just by using this mesh optimization. You can change the deviation area, you can change your different deviations, your different angles, your different lengths, and that's going to adjust and automatically update the mesh to clean it up, basically reduce the amount of triangles. Merging meshes. So this feature has been improved to allow you to merge different meshes in a unique one. So basically this command allows you to be able to very usefully align meshes from two different sides of the model, or unite the meshes to make one unique mesh to provide a different scan or by an STL import. So here's just a quick example of that. We got the upper mesh, we got the lower mesh, and you can see how we can merge those meshes together, and you can actually have the two unique meshes as well. So within reverse, we have mesh editing, and we can select the merge mesh option. We select the mesh we want to merge. You choose your different settings. You can choose what layer it's going to merge it onto. It's going to automatically make those updates and make those changes for you. So we can set that mesh by a color, and we can change the color, making it unique as well if we're not joining these meshes together automatically. And you can actually compare the meshes using this feature too by merging two meshes into one file. When we select the merged meshes, you can compare the two. So we basically selected both those meshes, and we can compare the two as well. Mesh to point. So this new feature has been added to give a different solution in cases that you have imported into the system and tools available that cannot be guaranteed to be edited or optimized. What this function does is it actually extracts point cloud data using the existing triangles as a reference. After that, the user can start creating the new mesh and proceed completely with the reverse process. So here's just a quick video example of that. So we have the mesh analysis options, and we have mesh editing as well. So if we do mesh to point right now, we select our mesh, we can keep visible points, and what it's going to do is it's actually going to create points on the existing mesh, so we can start creating a new mesh in reference to that. So as you can see how it's starting, or you can create the mesh. You can create a detail level, you can change the density values, you can change the maximum distance on border, and you can start increasing and decreasing the amount of points it creates off of that existing mesh. So if we confirm it, we can then start creating our new mesh off of that. So you can say fill gaps and select the different points and fill the gaps in to whatever our relevance area is supposed to be at, and you can see how it creates a new mesh in relevance to those points off of the old existing mesh. Change the average distance between points. You can change your different values, and you can basically modify that new mesh to reflect back off of the old mesh or make some modifications as needed. Analyze on mesh. So the analyze command on mesh has been improved to include both the availability of commands in previous releases and a unique feature where the user can easily switch between the two visualizations. The range settings and the relevant value is now more flexible and user-friendly. The user is now able to save and load them as templates. So for example, we'll go into the reverse and we'll do a mesh analysis, and we'll do the analysis off the mesh. You have the curvature and you have draft angles as well. So you can see the differences between the mesh here. And you can make relevant changes. So you can say the number of range. You can change that from 8 to 5. You can see how that changes the color values. You can see how that changes your different values here. You have the ability to type in whatever values that you want. And you can save that range or load that range. You also have a draft angle range, choosing the direction, and updates that draft angle automatically off of this. You see the values update. You can double click and you can type in the values. You can type in new percentages and so on. So as you can see, we have our different ranges in here, different values, and you can type in whatever value that you want in relevance here. So it automatically updates that analysis or that draft angle in relevance to the values that we're typing in. It'll automatically try to pinpoint and calculate the values in relevance, but you can type in your own values automatically. You can save that range and load that range, and it automatically retains that to load into another design. So you can select save range. It gives you the ability to save a snapshot, and then you can load that snapshot in to another value. So you can see we can save that. We cancel out of this. If we go back into it, you can load that range value, selecting the angle, selecting your different parameters. You can see how if, let's say, we type in a different range, when we load our range, it'll actually automatically change those detail values. So select load range, select our snapshot that we saved, it automatically retains and loads in that snapshot. It automatically updates the values to whatever we typed in, and it makes it easier to save templates to analyze your meshes. Curve on mesh. A new command option which allows you to create a section as an arc or a segment. So this system, or the system, uses different properties showing the section using just arcs and segments. Confirming the results, the system will automatically create a profile which can be easily edited and extruded as a solid entity. So the approach here is very powerful in cases of geometrical parts because it allows you to draw different sections and just extrude them as the final shape that you want. So again, a quick video of this. We can go into the curve on mesh option, selecting our mesh, and be able to pinpoint and click different points for where we want that section to be based off of. So we pick, let's say, our point, we choose the direction where we want it to be associated to, and when we hit preview, it creates a section. So that section can be turned into a profile, it can be turned into arcs, and so on, to be able to extrude and create that into a solid. So basically it makes it simpler to create your feature off of. So if we hit preview, it's loading that in, and you can see how it creates a section including the whole features within the feature in that relevant direction. So if we confirm it, we now have our wireframe to be able to extrude off of. You can see how it automatically created that into profiles, and then we can extract those profiles and actually turn those into a body section. So you can actually highlight different areas, you can clean up the mesh model, you can unite those into a unique segment, and you can extrude the element and extrude your dialogues. So you can see how we are cleaning up this mesh model using the body from section option and basically cleaning it up to make it, let's say, one segment, one arc, and so on. So think of it kind of like concatenate curves, but you're actually simplifying, you're actually joining these curves together, you're making it into one entity using this command. So within here, you can select different areas and you can start extruding those models out in relevance to the section that you created. It gives you some messages, let's say inconsistent pick selection, and it gives you some messages in relevance as it's going throughout its process as well. But basically this process allows you to start simplifying your areas once again. It allows you to join them together, making it one unique area. We can go back and forward on the results as well, so if you make a mistake, you can use the back and forward results too to extrude this area out. If we select extrude as body, you can change the first distance, and you've already made this into now a solid in relevance to the mesh that was already existent. So this is just simply based off the mesh, changing the sizes, and then making your necessary trims from that. So creating a simple model right off the mesh using those commands. So for example, we select the body of sections, and we're going to select some internal areas like our slot here. And you can actually start extruding the slot. You can create pockets out of the slot and so on. Again, change the result area going back and forward. You can unify those arcs as well. It keeps a unique color for each area as well. And it highlights different points to show you different areas of this. So you can join them together, you can unite them, you can do whatever you need to do with them. When we extrude this as a body, it extrudes it as a body into the part as well. You can do more or less and so on. So as you can see, we extrude that out of the body, which then can be cavitied out later. So as you can see, we can do a subtract or a cavity, and it's going to subtract that out of the body, basically making it so you're creating your part into a solid instantly. Cut mesh with element. This feature has been added to allow the selection mesh and more meshes. So this function allows you to select different wireframe elements as segments, circles, curves, or points. After cutting the direction, the selected mesh allows you to basically split the meshes into two different meshes. So this solution could be useful as an alternative function to imprinting as well. So you can create wireframe off the cut mesh and then after easily implement it into a surface. So here's just a quick video example of that. So under reverse, we have cut mesh with element. So we have a couple of elements in here. We select our mesh, we select those elements, and we can choose what direction off those elements to cut that mesh. So it's going to basically separate and split that mesh into two different entities based on that cut direction based on that element. So we select another element in here, we can cut those as well. So as you can see, we're starting to split these meshes in relevance to those elements. So we have our two split meshes in here using the cut body area, and you can make those unique areas just by simply cutting off of the relevant elements that we have in here. So this allows you to draw wireframe or create curves off of those relevant areas to be able to, let's say, create sections off of. So it's going to basically allow you to create sections and cut sections off of that relevant area to start creating our surfacing. So we can actually cut that mesh off of that current curve that was created off of the actual mesh and start splitting it and start separating it out. So this makes it easy to start splitting your mesh apart and start working off of specific areas to basically separate everything out. Project on mesh. This feature has been improved to add different methods to imprint the elements on mesh. So in reference to selecting the method, the system gives you the possibility to set different options to evaluate the results of a mesh. This is surely a step forward for this command because it represents another approach to the reverse part. So for example, we go into reverse, we select project on mesh, and we pick our wireframe elements to project on the mesh. You can project, imprint, and if we select the advanced imprinting options, you'll see after it loads the results in that it actually is going to imprint those wireframe lines on the actual mesh. So you can actually see those wireframe lines actually projected onto the mesh, and you can see the actual curves of it. So when we go into mesh editing, you can start selecting the mesh and relevance to those areas so it cuts the sections off of those relevant areas. Body from section. This feature has been improved to allow different approaches to the reverse process. So after a section is created by a curve on mesh or with the arcs and segments, this option activates the results for profiles that can be edited to use different commands, and at the end also extract them as solids or surface entities. So this approach is very powerful in cases of geometric parts because it allows you to reverse the part, such as getting the results from a Boolean operation on the solid and basically being able to allow you to extrude it as a solid on a mesh. Mesh to surface. This feature has been completely reviewed and improved upon to give different solutions to help the user create the surface starting from a mesh. So now in this command, it is now simple to create the ability to create a surface starting from the mesh in cases that the user splits the entities for the entire mesh in different meshes. It can be selected for each mesh to replace into a surface. You can do this off of faces in the case that the user has imprinted some faces with wireframe entities on the mesh. So the mesh is now subdivided into many faces. So the user has the ability to basically have the system replace the faces of the mesh into different surfaces. You can also do this by triangles in the case that the user prepares the mesh as a unique entity using the option to basically make it so you can select different parts of the mesh, replacing with triangles as surfaces. Using the remove triangle option, or remove the trimming option, the system can create the surfaces in easy and fast ways, and then with the CAD functions, trim it and unite it to make it one solid part, which would be available in short time. You can also do this off of elements, starting again with the entire mesh. The user can draw profiles and or close areas, and basically with different wireframe elements, basically let the system create the reference mesh and create the surfacing. So here's just a couple video examples showing the mesh to surface command. We can select your different areas and allow it to create different surfaces by the mesh, by faces, by triangles, and by the elements. You can change your surface tolerances, and when you hit preview on these areas, it's actually going to start creating the surfacing. This one by mesh here. So we split that mesh using that rectangle profile there, and it creates the surface and relevance to that. We can select the entire mesh as a whole, and we can select by faces, and you can pick certain faces of the mesh groups, and it creates a surface off of those relevant faces as well. We can also do this by triangles, so we select the entire mesh here again. You pick the relevant faces, and then you pick the relevant triangles that you want to be able to choose these from. So you can select the triangle group, and it's going to create a surface off of those areas as well. Very similarly to how it functioned before, you can select remove trimming. That removes the trimming off of that, making it a clean, planar surface. And then selecting the mesh one more time. We can do this by wireframe elements. So we select this wireframe element, we can select the curves, and you can create the surface off of that wireframe element. So the wireframe created off the mesh can be now turned into a surface. You can remove the trimming as well, and it's going to create a nice clean planar surface off the relevant area. So remove trimming will actually trim that wireframe, or trim to that wireframe. So repeating that process again here. We select the elements. Then hitting preview, you can see how it creates a surface off of that. You can keep the mesh value in there as well. So you can compare the surface to the mesh using these commands. One-click surface. This feature has been redesigned to guarantee that the achievement of this command gives you good results in most cases. The system creates a 3D grid around the mesh and allows the user to decide to draw the grid or just create the relative surface off of it. This command is very useful if you would like to just have a surface result and a one-click solution. And so it could be used during a demo, or it can be used in all complex parts, where the other approaches could complicate the use for it. It represents an alternative solution to a standard mesh for surface creation to move from a mesh to a surface in an easier way. So in just a quick example, we're going to select the one-click mesh. We pick the mesh as a whole, and then we have the options under output for grid, surface, and both. So if we select grid first, you'll see it's actually going to create that grid, and we can also keep the mesh visible. And then if we select surface or both, it's going to create both the grid and the surface at the same time. So it's going to create a surface using that grid option, using the different parameters up at the top for merge management, and it's going to create the surface as well as keep the grid in there as well. You can unite the surfaces together, and you can set unique colors and put the surfaces onto a unique layer using this option as well. As you can see, it creates a surface, it creates a grid for you automatically, and it's going to create that information within one click. So great for demo purposes, great for actually just creating the mesh as a general alternative solution when it comes to doing reverse engineering. And here's just, let's say, a stopwatch here. We're going to do the one-click mesh. We're going to set it to both, and when we hit preview, on something complex like this, it's not going to really take too much time to actually create that surface. So at about, let's say, a minute and 45 seconds or around that time frame, it's going to create your surface for you. So as you can see, it's doing the countdown here. And it created that in about a minute 50. So it creates a very complex surface off your part in a very little amount of time for demo purposes. Of course, it may not be 100% perfect, but it's creating a surface very quickly off of your mesh model. Plane and radius from mesh. So a general constraint method has been added to allow you to create a surface using a work plane as a reference without any picking of directions or surfaces, which are still valid as alternative options. in the radius from mesh command, you have the ability, or it has the ability to output selection, and the user can select and create surfacing or a solid. Sphere from mesh. This feature has been improved, adding the possibility to create a sphere starting from triangle selection. This helps the user during the conversion area, identifying and giving more opportunities. Cone from mesh. The command has been completed to review to help the user in a better cone definition. So now the user can define multiple points on a mesh as a cone base and other points on the mesh as a cone top. After that, it is possible to adjust the cone to detect the values to create a surface or a solid. Moreover, a general constraint method has been added to allow you to create the surface using a work plane as a reference without picking any directions or surfaces, which is still valid as an alternative option. Surface from cloud. This command has been updated, adding a general constraint method to allow you to create surfaces using a work plane as a reference without picking any direction or surface, but it also provides a selection direction or a surface reference as well. So this improvement aligns this command to the other commands that allow you to create a surface, and so this solution could be an alternative solution to reverse apart, avoiding creating a mesh. It can be used when it is necessary to have a mesh, but you need just a preliminary surface of the model. So here's just a quick video example of the last couple of slides we were going over. So we can select the plane from mesh, basically clicking some different points on it, hitting preview, and allowing it to snap to a work plane axis. So you can see how it creates that surface in relevance to the point and relevance to the face direction. So literally I'm just picking one point and letting it snap using the work plane axis option. So if we hit preview, it allows you to continue that command as we go throughout our process here, and it creates a plane in relevance to the work plane setup and relevance to that mesh. So for example, if I do a query angle off that from face to face or face to direction, it tells us what the exact angle is in relevance to that. So this is just verifying the work plane angle, work plane orientation, and so on. So if we do face to direction on this one, it tells you the exact angle of it in relevance. So if I go to radius from mesh, I just pick a specific point on this, and I can allow it to align it, create the mesh value, and we can snap it to an exact work plane. You can see how we just pick one point and it creates the surface from the mesh. We can also turn this from a surface to a solid automatically as well, and so on. We pick a different part of the mesh. We let it create it from the preference off of a previous selection, and it creates a surface off of the preference of the previous selection as well. And change the radius values of that as well, and confirm. So from here, we can go into sphere from mesh, basically picking our triangles and letting it create a sphere off of those triangles. So we can do a specific radius value, let it get the exact radius value of what it's creating. We can create a sphere from that mesh as well. And then we can do a cone from mesh too, using the other mesh surfacing commands. And when we pick our cone from mesh, we just pick specific points off of it and allow it to create the cone. So as you can see, in relevance to all the points that we picked, you can make that cone a surface or a solid based on those relevant points. Alignment. This feature has been enhanced, updating the core function, increase the percentage of success with inertia methods. In some cases, the system could give you an inverted result, and so has been added the option to reverse the X and Y directions in this method. Moreover, the point selection has been improved on the points method to help the user select the correct reference point on the model. Additionally, it has been added for the possibility to select multiple entities as a reference for the alignment. So in this video example, we're just going to show you some examples of the alignment. So we select this point cloud that we have scanned in here, and and we select this point cloud scan in here as well. So we let the process load here, and then we hit preview, and we can choose to try to align those. So for example, it doesn't look like it 100% aligned it perfectly, so we can invert it in the X and invert it in the Y to basically do a reversal of it. So we have a top and a bottom, and then when we align them together, they're now realigned properly. Compare. The function has been completely revised and improved upon to give more flexibility and better evaluation of the results. In detail, the user can now set the number of ranges, which can also be saved and reloaded. So if you would like to evaluate with the same distances, same settings, it can be saved as a saved range. The color bar has also shown some percentage improvements for points on each mesh in each range. In this case, the comparison of a mesh within surface and solid is now possible to set the smoothness, which will be applied to the color bar, but also to the mesh, which gives better view and comparison results. Additionally, it has been added to have the possibility to select multiple entities as a reference for comparison. So here's just a quick video of that. So we have our solid model and we have our mesh model that we can reference and compare off of. So when we load it, you can see how we're comparing the two bodies together. So we have the ability to save and load a range, that's what was mentioned, and you have your different custom color ranges as well. So you can see how it loads it in. Most of it's blue here. You can show the smooth color bar as well, so we can select the smooth color bar to see how smooth this dialog is. So you can see your percentages, you can see your distances in the dialog over there. You can control the number of ranges as well by typing in how many ranges you want, and you can type in whatever values you want in there to increase and decrease how that range value is going to load. So as you can see, we can make these adjustments in here and add and subtract whatever values we want inside this color bar. If this is how we want it to be set, we can always save and load this range in as well. So you can see how when we increase and decrease the numbers, you can see how that range value is going to be selected. We can select the distance on the node here, and it's going to apply that distance value and apply those ranges based on what is selected here, and also determine the color code from that. Now we're going to go into some of the features that have been created within the mold area. So we're going to start out with body to mold, mold to body. This feature has been enhanced, adding the additional options to help users create the mold position part. So the system is now able to manage and select wireframe as an additional selection, which you can make to predefine work planes or existing ones. So you have the ability to define the mold position within this. So here's just a quick example. So we're going to select body to mold in here, and we'll pick our part. When we pick our part, we have the ability to pick additional parts as well as wireframe. A couple of new options in here is called use existing work planes. So if you already have work planes set up, you have the ability to use those existing work planes inside of the piece, which is nice. So if you have a second revision or an overlay, you have the mold work plane and the body work plane that which can be referenced. So for example, if I go ahead and delete these out, and then I go into here, I could change the color of this. And when I go into here, I could change the color of this as well. And when I place these back into the body position from mold position, it will actually retain the wireframe elements, and also, since we set the scaling to a bigger size, it also will scale that back to the original size. So we pick the solid and the wireframe that we want to be repositioned back. You can see how it automatically resizes it back to do some comparison models.
Tool design. Tool design has been improved with performance, speed, and logistics when it comes to creating a mold base. Some of the catalogs have been updated following customer information. In detail, the DME catalog has been updated, so it's now possible to define user pre-drilled plates in both units. Within DME, there is now an A and B series of components as well.
So here's just a quick video example of that. So within tool design, if we select DME or DMEI, you now have the ability to choose A series and B series plates. So we select these options, we select the B series, we select the A series, it automatically updates in relevance to those. We can load the standard elements, and it loads the standard elements in relevance to the A or the B series of components. So as you can see, it loads all the components in. We can change relevant sizes of this. So the DME catalog has been vastly improved upon as far as within tool design, within standard elements as well. So if we change this to the B series now, you can see how we can change this to the B series as well, and so on. So the same thing applies to the DME, just the standard metric DME. We have L and FM plates as well. So you can change your different components. So as you can see, the DME catalog has been vastly improved upon, as now there's 2 lists to select from, both in inches and millimeters, whereas previous it just had 1 component library to select from when it comes to doing your tool design. And also within tool design, you have the ability to select non-standard parts and allow it to load them in, and then when you load in your catalog, it would automatically pick the sizing based off of those relative parts. It automatically fit the plates in as they're supposed to be and insert the components in as needed as well. So as you can see with the DME catalog, it loads in the components as needed inside of this relevant area. Within Tool Cavity, this feature has been enhanced, and you now have the ability to automatically add blends as you're creating your tool cavity as an option. So on this detected corner, it makes it easier to machine these plates. So here's just a quick example of that. So we go into Tool Cavity, we pick our cavity here, and then we can pick the relevant edges off that cavity. So you can see how it creates those edges. We now have the ability to enable a blend radius off of those edges, making it easier to machine these parts. So previously you had to manually go back into the blend command. Now the blend command has been built into the tool cavities command. So as you can see, you change the clearances, it would automatically retain or add those radiuses in. Cooling. This feature has some new options added as well, which allows you to create the safety solid circuit when it comes to the system. The system creates a solid and it sets a safety diameter using the solid as well, so you can tell the system to be able to create that safety zone so you can make sure nothing is colliding within the safety zone. The safety zone also is improved so that way it is in relevance to the cone and the sphere, and it adds that safety diameter to those as well. So under properties, we have cooling safety circuits where you can add a safety tolerance, you can add the safety transparency, and you can add and change your radiuses for that safety zone. So when we're drawing something in automatically, you'll see the outer diameter is going to be your safety zone. The blue diameter is actually the radius itself. So since we have a cone shape, you can see the safety zone is in relevance to that offset off that cone shape. So if there's any collisions within that safety zone, it will let you know as well. So we can change our tip type from conical to spherical, and you'll see that safety zone also will interfere with that as well. So you can see how we have the circular, the spherical, and you can see how that offset is updated in relevance to it. Same thing if it were flat as well, you'll see it's going to update that. So we can pick our safety tolerance and change that tolerance as well, making it bigger. You'll see the relevant safety zone size has actually increased. So you can see how we have that different safety zone tolerance in there as well, whether it's conical, flat, or spherical. So we can create safety circuits in here, so we can actually do the offset value for our safety circuits as well. And you can, when you're adding injectors, when you're adding anything in there, you can have it easily detect if it's going to collide within that safety circuit. Now we're going to go to some of the new features within Flow. So there's a new filling phase calculation that has been improved to basically create a considerably satisfactory result, obtaining holder modules, where the algorithm has been introduced to the previous version to basically benefit for the entire simulation chain. Not only does this give a better flow pattern, it also determines the fiber orientation calculations. So this new filling algorithm checkbox allows you to do the filling dialog changes. So there's some new calculation engines built into it. So we're going to have a couple comparisons. So on the left, we're using the same results with the new filling engine, whereas on the right, we're using the previous algorithm. So you can compare the results between one and the other. So you can see the differences between one and the other, so you're getting a more accurate result based on the new engines. So some additional improvements are shown on the left part versus the right part, showing different thicknesses which have been considerably improved upon. So you can see the difference between the left side and the right side when it comes to calculation. So the flow's hesitation is much better by considering the new filling calculations on the left image versus the right here as well. And within the new calculations, there's a more precise flow pattern, which now determines also with regards to real part, as shown on the left, versus as shown on the right. So you can see the real part in the center, you can see the results on the left, and you can see the results on the right, and you can see that there is an improvement in regards to those. So also for this model, you can also determine the thickness distribution that should be refined, and the predictions of the flow pattern have been greatly improved upon. So you can see the flow predictions on the left side versus the right side, and you can see how it's vastly improved upon. We have some new options within shearing stress which have been added to the list of variables when it comes to part selection. We also have some new holding phase calculations, unlike the filling module, for which the implementations of the calculation algorithm has been brought to considerable advantage in terms of quality of the results. In this first release version of the calculation times, which have been significantly lengthened, an enormous improvement in the calculation times of the holding phase has been obtained through the passage of the data in memory and no longer on the file. So now we'll go into the new features within Progress. We're going to begin with the part unfolding. To improve the unfolding approach, there have been some features added to allow the flange to manage parts with nonlinear bends, preserving the possibility to modify those nonlinear bends afterwards. The goal is to build a new unfolding solution, which is to provide a powerful and easy solution to study and modify the parts, preserving the links between different unfolding steps. Within part definition, the feature has been improved to allow better and faster automatic part analysis, identifying different face types and different relative materials to set the linear bends unfolding methods. The automatic feature recognition has been improved to automatically assign the right properties to the relative faces. The user can also define the part name, also set as a description in the Assembly Manager field. A new custom option has been added to manage natural custom fibers, and this way the user can easily add custom neutral fiber values directly to the dialog, and it will keep it in all of the next steps. So here's just a quick video example showing the part unfolding. We'll start with part definition where we pick a relative face here. You can see how it automatically selects and searches for different sharp edges, different values. You can go into here and you can pick different faces here within the part definition as well, and it automatically is going to find those as a specific feature. You can go into the unfolding data and you can set different natural fiber values as well as set the neutral fiber value, and you type in the value that you want. So basically controlling where your fiber value is or where it's going to be starting the unfold from. You can change different colors to these different values as well and change the relevance of them. We go to confirm, you can see how it changes the different colors by default. If we go to step unfolding, we select those different values. You can see how it retains the colors in as we're doing our unfold process. Select our other value in here as well, and you can see how it starts unfolding that one. Same thing applies here, whereas you can see when we select that unfolded value, you can see all of the other values will retain, including that rib in there. We do a part definition again. We select this relevant face this time, and you can change the start face on the fly as well. So we select change start face. We can change our start face here, And then we can add a different application point for where our strip application point is going to be. When we rebuild the links, it's going to update all of the other relevant ones to that specific direction, automatically changing the orientation of this unfolded part. As you can see, it changes all the other stations as well. So within part unfolding, we can select step unfolding again, picking this area, changing it to a different fiber value. And when we go to confirm, you can see how it unfolds in relevance to that. So it changes actually the color of the face to it automatically as well. Step unfolding. So there is a new setting for flat length and a comparison radius within step unfolding. Another new enhancement is an option for before the blend or linear extension after the blend as well. And the system now splits the results between the two faces. The system now highlights the faces causing problems during the step unfolding process, so you can easily see where the problems are to be able to make corrections and fix them, and then redo the process as needed. So here's just a quick video example of the step unfolding. We'll first of all define the part definition first. We can set our different fiber values in here as well. And then when we confirm it to rebuild, it's going to build based off of those values. So under progress, we select part unfolding. And it's going to create our blank result here. And within part unfolding, we now go into step unfolding. And we can select our different value. We can change the length of how far that station is in relevance to the other one. And we can change our bend angle as well. So as you see that rib is actually existing in there still. So you can go and confirm that. And you can see it actually adds an extension blended edge there as well. So we can set the fold before and after, and it adds that edge in there automatically in relevance to the actual blended area. So when we unfold it, it actually will then simplify it. But before that point, you can add that edge in before or after the blend and start doing your unfolding process from that. From here, let's say we have a punch that's subtracted out, we can actually go in and we can actually create a cavity off of the blanked part, and then we can update the other parts to show that relevance. So you can see how we've made a modification to this actual part, and instead of having to actually pick the main part to do the updates, we can actually now go into part unfolding and we can rebuild off the blank, or realistically rebuild off of any of our unfolded parts. And you can see it updates all of the associated parts that were defined with the part unfolding. So no longer do you have to do this on the original part, you can do it off the blanked part. So in this example, it shows the step unfolding and it highlights any problem area faces where it's having trouble with trying to create the unfold from. So we can actually edit that analyze face or edit that group, and we can change this feature type, which may correct that problem. So we go back into step unfolding, we change that feature type, and it now allows us to unfold that area. We could also fix that surface area as well, which would also do the same thing, but this is a lot quicker. And it highlights the area, which is nice as well. Part unfolding. The binder selection has been added to blank the part in different steps using the custom builder surface. A results page has been reviewed and clearly situation about the different visualizations helping the user on the blank results. And here's just a quick example of this. We're going to find this with part definition first. And then we're going to go into the part blank unfolding. So we select our part. It's going to create the blank for us automatically. Now, as you can see, we can uncheck apply thickness as well, and then we can map our edges onto the blank part as well. And then we can actually constrain this off of an XY plane. You can constrain off of a face. You can constrain off of whatever you want. So if we select face here, that's going to be exactly what's constrained to. And that's where it's going to determine its orientation from as well. You can type in your values for the X, Y, Z locations too. As you can see, you can adjust your Z value. You can adjust wherever you're moving this to. And then you can also reset the constraints as well. So basically reloading it, reloading constraints. You could do a blank holder force. You can do a pressure pad force. And it will affect based off of those values too. So just like with the standard VISI blank, you have these options inside of part unfolding now. Adjusting the different pressure pad forces, the total force, and so on. So inside the results tab, you can see these different variables added into it. You can see the thinning results. You can play the thinning results. You can see the safety zones. And you can see the forming limits. So as you can see, it's populating those different values in there. We can do the spring back on mesh, and you can see how the drawn mesh, the blanked mesh, and the spring back mesh are showing up with what they're showing up as well. Then going into thinning results, you can also display that and kind of flip back and forth between the different filters. You can play and simulate how it's going to show up, and this is very similar to, like I said, VISI blank, where you can do the same thing, but this time on the solid part, and you can actually simulate it off the solid part too. So we're actually displaying different custom points to show where our different thicknesses are, the strains, and so on. So it's applying the different information based on the point selected, showcasing what the differences are between one area and the other. So as you can see, it does create the blank results in relevance to that. Part flange unfolding. The tangent binder option has been enhanced to preserve the face types and adjacent faces as a result to the flange operation. This is a big step forward in the unfolding process. So basically what happens is when you define a flange, you have a flange area added. When you unfold it, it actually automatically adds it in as a plane, as a blend, and so on. Another important option added into this is the constrain face option within flange. Using this type of option, the user can now decide to split the flange process in more than one step. So as you can see, you can split this between more than one step. The result page has been reviewed to clearly situate about different visibilities, helping the user use the flange unfolding result evaluation. So we're just going to showcase some of the new enhancements within the flange results. We'll start out by going into the analysis. We're going to define our areas first. Then when we go into edit analyze faces, we're going to edit the analyze faces for where we're going to actually define our flanges off of. So you can define them off of this as a flange automatically. So we're going to define both sides. And then from there, we're going to go into the part unfolding on a flange. So we do the part unfolding on a flange, and we select it, let it process. It's going to basically build the information off of that. We can then see that it's automatically updating the colors after we've unfolded it. If you go into the 45-degree angle and map the edges, you can see how we still have our mapped edges and relevance to it as well. So it'll automatically update it, and then we could do a two-step flange on these specific areas. We'll repeat the same process on the other side. And then go ahead and confirm it. And then we could select that flange again and do a second station. So you can flange unfold in two different steps. So we can add a new step, and you can see how the colors are going to automatically update, so that way it defines as planes and as blends as we're going throughout this process. Repeating that same process on the other side as well, you'll see the other side is going to update in relevance to that as well, making it so those linear flanges can be all selected at one time. You can see how in the results area, we can define the thinning results and see the specific area used in flange unfold. You can see the safety zones inside of this, as well as the spring back and mesh areas. You can display forming limits in a diagram as well, and again, showing the spring back areas. So you can view specific areas inside the part unfolding, much like you would do just with the flange unfolding inside of the standard progress dropdown. So within this as well, we'll go into part unfolding, we'll go to step unfolding, and we can continue on with these stations and start unfolding them. So we just select one area, we add that new step in there, we can add our new bend angle, and you can see how even though we define those with flanges, it still retains the colors and allows me to continue to move on with this in different stations to eventually get my blanked part. Our final station, which would actually be the blank part. So as you can see, we start out with our flanges, and then we move on to our linear bends and start doing the unfold process from there. In this example, we do the part flange. We can actually specify which faces are going to have bends in it. So you can select surface constraints, and you can choose the specific surfaces that are going to have some constraints to it, and you'll see that it's going to automatically add those surface constraints to the part we're trying to unfold. We can select the same thing over here, and we can set different surface constraints for this as well when we select our linear flange or our flange unfold here. You can see when it loads the process, you can see how it's keeping those face attributes as what they're supposed to be. So basically setting certain face constraints so that way it doesn't unfold those, or that way you have more options when it comes to the unfold process. Flange bender curve. So this feature has been added to allow the user to create binder surfaces. This is useful to create, let's say, a case where the user would like to add a custom binder, and the results of this function can be used at the starting surface to modify. Display part results. This feature has been reviewed and enhanced to better create a user experience when saving time during this process. The user can now select the part to analyze, and the system shows the calculated results, allowing you to show and select the visualizations. In the case of linear unfold, the system will allow visualization just on the part or the mesh within the calculation stress. In the case of flange or blank options instead, it allows you to use all visualization modes. So here's just a quick example of that. So within the display unfolding results, you can select different parts here, and it shows all of the different parts. For example, the blank, you can see the thinning results of that specific blank, and it shows all of the possible areas. So for review further after it was already created, you can review the different results of it, and you can make the modifications as needed as well. So you can see the spring back, you can see your thinning results, you can see your safety zones, and so on. So we can actually view each part and view this visualization for each part at one time. For example, we have these flanges. You can view the different options or different dialogues within each part and within each flange. See the results of each part at one time, which saves you time because you're being able to view this all inside of one module without having to reselect and repick. So again, you can say show the part, you can show the different bend, you can show the thinning results, you can show safety zones, and so on for each individual step defined with blank and the flange unfold. So we can also display these parts inside of a tree here. You can see the different planes. You can just see anything you want as far as this. If we go into here, you can expand this, or you can see how some of them have expanded drop downs. You can see what the differences are between each one of the parts. So you can highlight each part and see what the differences are between each one. You can expand them down, you can see the flanges, you can see the bends, much like how you would do within the part study area. So as you can see inside your part manager, you can see the bend angle, you can see the original angle, you can see the setback, and so on. If we select different parts, you can see the different results for each one of those parts. You can see the natural fiber values. You can see anything that you want to see within the part manager, and displaying your different properties. So now we're going to go into some of the new features within standard elements. Within the mold progress sensor elements, based off of customer feedback, many of the catalogs have been enhanced and adding some new standard elements to the updated existing libraries. The most impacted catalogs are including the DME, Haskell, Museburger catalogs for both units, inches, and millimeters. A couple of new catalogs that were added as well inside the mold area are the NAR catalogs, as well as inside of Progress, you have the TIPCO catalogs. There's a new option inside of the standard elements also, which is called 3D Find It. In the standard catalogs, this new online catalog allows you to search different things through the Cadenas dropdown. This allows you to choose different parts, including projects from huge supplier lists in different types. The registration is free to this, and it allows you to bring in 3D data from many different suppliers. The catalog information is added into the assembly manager when importing in the solids as well. So here's just a quick video example of this. We go into the Cadenas dropdown, we select Load 3D Find It, and it populates the online catalog. Of course, this requires internet to be able to do. So if we search the catalog, we can search for the specific mold components, mold base, and so on. So if we go to mold components, you can see your cooling components, you can see your cavity components, you can see general components, and so on. So it provides a very large list of different components. We select from these components, searching for return pins, ejector pins, guide pins, cap head screws, dowels, and so on. So as you can see, you can insert that in and bring that right into the VISI software as a solid data file. So when it loads it in, you just bring in that component, and so on. So thank you for watching. So I'm going to open up the floor to question and answer. If you have any questions, feel free and ask, and I appreciate your time.